Okay, me again. So I was asked to quickly talk about Dash CMAF, and I added CTA Wave because that seems to be relevant. I'm not responsible for CMAF, so I'm just bringing over the message. So don't shoot the messenger. I am involved in CTA Wave, so I have some connection to this. I'm going to talk about this. So what is this whole idea about? So why is there the idea of Dash, CMAF, and so on and so on? That is basically, I think, the problem that started the idea. And maybe it's simplifying it, but basically we have many different players. We have different players in the service offering, and predominantly we have different platforms and players. More and more come into place. So we have, on the player side, we have standalone HLS being used in HTML5, so video tag browsers. We have standalone Dash client, for example, HBTV has this. We have Dash as an HTML5 video tag, so they're native Dash clients and browsers. And then there's also the whole work on the MSE-based Type 3 playback, where the manifest is parsed in JavaScript. But anyway, so the basic idea is that you generate content once, and you distribute it once efficiently in a CDN, broadcast, or multicast scalable environment. And you can then integrate this into your application and can use existing streaming formats. And the basic idea was to basically harmonize HLS and Dash. So that was basically the idea around CMAF as I see it. And obviously there are questions now on the decoding and decryption platforms and so on and so on. So that basically was kind of the idea of CMAF. And it started 1.5 years ago, and there was proposals being brought forward, which on the requirements, there was many co-signing companies. There was already a technical proposal, which was proposed by Apple, Microsoft, MLB, a couple of others. There were LSs being sent out, including to broadcast organizations, and then there was these documents being developed. Where are we now? We are now at basically that we have an FDIS-approved common media application format, which will be published by ISO, hopefully, let's say, by the end of the year, the latest. There is some amendments happening, which adds additional media profiles, and there's a working draft started on additional media profiles. And there is also work plans for doing all the conformance. So I have some older slides. I apologize, I didn't have much time to prepare the details of the latest, so it says still committee draft, but that's also on the final. So it basically, what does CMAF contain? So the specification out of MPEG. It's basically talking about the basic idea of the object model, the definitions, then there is the file format aspects about this, the encryption aspects, and then for the different media types on video, audio, and subtitles. And then there is a definition of presentation and media profile with informational annexes. So that's available, and basically there's terminology introduced, and you might want to remember a few, you might forget a few, because I think it's overloaded with terminology. Again, I'm the messenger and not the inventor. There are presentation profiles. The basic idea of presentation profiles is that you basically define a minimum set of media profiles, which can be audio and video, which you can combine, and encryption schemes, in order to be able to offer content and play it on specific devices. Then there is the idea of individual media profiles. So for specific media experiences, together with the codec, you create all the detailed definitions of the file format integration, the elementary stream constraints, and put it into the specifications requirements for the content authoring. And then you can offer basically this in what is called a switching set. So that's primarily what is inherited out of Dash being an adaptation set. So something, we have multiple tracks or multiple offerings of the same content that can then be seamlessly exchanged and switched in order to allow adaptive bitrate switching. And then you basically have compatibility brands for addressable objects, and those addressable objects is what hit the networks, which were actually resources. Okay, that sounds a bit strange because it's very terminology loaded. That explains it a bit more on what are the resources, what comes together. So basically, what it just does, it's the whole idea about the file format-based streaming is to create objects and units which are meaningful for itself and can be distributed independently and processed independently. So what you see here is basically, you also find it in Dash. They are called slightly different, but at the end, they're very similar. So what you have is a CMAF header. The idea of a CMAF header is to basically give all the static initialization information in a static information blob. That's basically what you see from the outside. Internally, you add a file type, which gives you a brand, and the movie header, which has all track information, decoder information. It initializes the decoder. Then you have a CMAF fragment. That's a sequence of basically samples, so video frames. And the duration is typically a second, 2 seconds, 5 seconds, and so on and so on. And they are built out of chunks. But let's go to the chunks. So the chunks' basic idea is that you have information which is targeted for different system levels. So you have information which goes to like the packaging system. So you can identify what type of chunk it is. And chunks are differentiated. So in the final draft, there's 2 types of chunks. Basically, one chunk says, I'm a regular chunk, which you can just distribute as a unit. And then there are specific chunks which tell you you can randomly access and switch at the start of this chunk. So basically, the chunk is constituting out of information which are for the system level. There are 2 types of information included there. One is the e-message box. So that's an information which is targeted to an e-message processing to do some event dispatching. It doesn't go into the media pipeline. There's a PRTF. The PRTF is for synchronization purposes and for drift compensation. And then you have the regular file-formatted movie header, which gives you all the details of what is type of samples are included. And then you have just a dump of the samples. So that's basically the structure of a chunk. And now you can aggregate chunks into a fragment. The fragment can be one chunk, or it can be multiple chunks. The multiple ones are relevant for the low latency. Then you can aggregate fragments into segments, so you can have a collection of segments, a collection of fragments integrated into a segment. And then you basically can build out of CMAF header. So what you can basically do, you can distribute CMAF headers, chunks and segments independently as units and blobs, so as files, something which cacheable in the network. Or you can aggregate those into a CMAF track file. So that's basically more for on-demand storage type environments. So that's all basically just basic structures, and they have assigned some properties. And the properties are there, as I have explained in my earlier presentation, in order to basically enable independent distribution of chunks, accessing content, collecting the static metadata, and so on and so on. So you can now use this generated content and integrate it into your environment. So there's a more detailed busy slide which explains switching sets. The basic idea about switching sets is that you basically are enabled to have one source content and encode it in a way that it can be collected in a switching set. And by doing so, you can enable that you can exchange the content on specific splice points. And that's basically what is the case here. CMAF only defines what you would be highlighted here in this light blue. There's a lot of aspects which you then need to do outside. That's what the manifest does. The manifest basically would point to the resources, and the resources would have assigned typically a URL, but it could also be that they're assigned just other types of object identifier. For example, if you do broadcast, then you can assign object identifiers which create the sequence. But you need to also have a sequence in place. So the manifest refers to this. Now the manifest can be, it can be an HLS manifest, it can be a Dash manifest, it could be your own, but they all would refer to the same encoded content. What you see here, you need alignment on this, basically on encoding, on encryption, the encapsulation, and also the pointers to the resources need to basically be the same in order to be cache efficient. So, and then the collection and switching set is also something which needs to be expressed in the manifest that you explain your streaming client, how you can use these different resources in order to do adaptive bitrate switching. And that's happening for video, that's happening for all the media types, and that then constitutes a presentation. So that's the basic idea, but it's abstracting it more from the content generation side. From a content generation side, you basically generate content which then can be integrated into distribution systems. So that's the key idea. There is media profiles now defined which are specifically targeting different environments for different codecs, HEVC and AVC. I don't want to go into the details. It may be that there are already too many, maybe there could have been less. There's audio profiles in the core. We only have AAC and a couple of media profiles for subtitling. Subtitling is always, it's like encryption. There's way too many. There is not, so there's always an argument whether you're using something WAP-oriented or more like TTML, but the agreement on the presentation profile was basically to focus now on the TTML IMSC1 text-based. Okay, so this is basically what CMAF is, right? So CMAF basically puts structure into encoding and puts structure into all of these aspects in order to abstract it from an encoding and packaging point of view. Is it something new? Well, I come back to this in a bit, right? Because it's nothing new per se. It's just like abstracting it to something to potentially agree that two ecosystems can work together, and there was just the creation of new terms. There was some value in basically fixing certain aspects. I agree on this, but generally, it is not a huge invention or nothing new. It's really more like just documenting what was anyways done until now. So CTA Wave was basically generated to build an ecosystem around the idea of CMAF. Wave stands for WAP Application Video Environment. And basically, the idea is now what I had before, that you had multiple content formats to leverage this and basically put ecosystem around these inefficiencies of having different codecs, different encapsulation, and so on, because that is cost in terms of storage and so CDN delivery, and so on and so on. CTA Wave goes a step further, and that's something where I think it's important. It's also looking into the device playback. So you not only can look into the content generation, you also need to have devices which are tested against able to play back the content. That's one of the issues we have identified, that there is aspects which work well if you constrain the content, but there is also aspects which but once in a while you need to constrain the content so significant that basically you lose a lot of efficiency. So the basic idea is to create more interoperability here. And here's a list, and I think that also comes from Ali. So that's what we're working on in CTA Wave as well, is to basically solve issues of playback in these different environments, that you have very clear test event against the content to basically solve these aspects. And then you have a reference platform which you can use, at least that you know where you implement. So that's the idea of Wave. And then you also basically having test material around this in order to develop your devices and to also check your content that it conforms to be played back in this large ecosystem. So that's basically how the Wave project is structured, where you have a content specification which predominantly uses what CMAF has defined, but makes it then the compatibility for Dash and HLS. Then there is a group where Ali and I are involved. I am the chair. Ali does the spec editing for the device playback requirement. That's relatively unique. I have not seen this done for streaming before. That we basically look into the aspects that if you get this content of these different units and chunks which are fed into a media pipeline, that you ensure that you can do operations such as switching, such as add splicing, such as synchronization, and so on and so on. So whatever needs to be done to operate this as a streaming playback environment. And then HTML5 is used as a reference platform with all the APIs from HTML5, predominantly using the HTML5 APIs and the media source extension and EME in order to have a reference platform. It does not mean that the content and the device are restricted to HTML5 only. We only use HTML5 as a reference platform. And then around this, basically, there is an organization. And these three groups and task forces are basically supported by a test and compliance regime, which then makes sure that the different actors in the system can do independent tests in order to get a broad reach with content. There's a broad membership here, and as Comcast is a steering committee member, the same for Qualcomm, which I am representing. But there is, most importantly, also you see Apple, Adobe, Microsoft, the CE vendors are present. So I think it's a good collection of people, but it's a tricky issue overall, because you're operating not only into looking into the future, we're also looking very much backwards. So there's a lot of question on existing devices, legacy. So where do we basically draw the boundary? That's the question. For example, encryption is not solvable because we're talking about legacy devices versus looking to the future. So it's a very, very difficult question. The same happens obviously with codecs. So there's always the question, how much do you constrain the content to work on legacy devices, and how much do you build devices which are future-proof to work with new innovation? I think that's a continuous struggling, but hopefully with having the framework in place, these issues are solved. So the question is CMAF and waive the end of Dash? And I have a very personal opinion as a disclaimer here. Actually, I don't think at all. It's very interesting that basically we're going back 5 years, because what is defined in CMAF as the HD presentation profile, that's what we published in Dash AF as Dash 264 ABC. And actually, what we have is that Dash 264 ABC content is CMAF conform. And again, give you 3 proof points for this, which we have been working on recently, just to give you an understanding. So first of all, the CMAF conformance, and again, Vakar is sitting here, he's doing a lot of work here, is basically largely just taking the Dash conformance, and we do like a couple of fixes or updates, and the updates are more like constraining it further, but not necessarily something which was not obvious from the beginning. Then if you use this conformance software, the conformance software is basically checking all the shell statements and the CMAF specification. You run it against the Dash test vectors to what CMAF defines. And you find out that all the vectors basically conform. So what we developed 2012 as test vectors is today CMAF conforming. So there's no news there. I think the third aspect is really interesting, and again, if you have time, talk to Vakar over lunch. So he developed with a student a tool that allows to play back the Dash test vectors using a JavaScript conversion from MPD. So you download the MPD locally into an MCU8, and then you basically can push all of the existing Dash vectors to an iOS device and play back or to an HLS client and play back the same content. So there is a tool here which is public domain, public open source. You can go there and basically start it on the iOS device. So you can play back the existing 2012 Dash vectors on iOS by just doing a small JavaScript conversion. Where do we move from here? I think that the encryption problem, which was mentioned before, will remain. It's not expected that this will be solved. Neither CTA Wave nor CMAF has solved this. And I don't think it's easily solvable. I hear different opinions. So the 2 catalogs for these 2 devices will have to exist, or you need to do on-the-fly encryption changes and so on and so on. It also seems that these issues are not easily solvable by the ecosystem, because whereas HLS moved towards CMAF, and which basically means it's isofile format. As you see, it's dash aligned. It's not obviously spoken out, but it's the case. The encryption problem will remain. I also believe that Dash is years ahead than what is basically the basic interoperability in CMAF. So we have a lot of interoperability around new codecs, HEVC, actually even added recently VP9. We have multi-channel audio, we have HDR, we have next generation audio, we are about to start virtual reality, we have low latency. So many of the questions which CMAF have not even discussed are already in place in Dash. So we may have to check if this contradicts what is defined in CMAF, and the expectation is no, as it's basically just CMAF has adopted a lot of the Dash concept. But CMAF is currently silent about this. So we have started the basic test and conformance checks. That needs to be moved also for the other profiles. But the expectation is that there is no change in the workflow if you have a Dash workflow, that you cannot use it, but you can leverage the content and hopefully move it over into the entire CMAF system. I believe we need to continue the innovation based on the practical problems. So as I have spoken about the latency issues, we need to integrate the different codecs. We have requirements that we need, for example, multi-channel, we need UHD, we have VR aspects. So all of this needs to move. And I don't think we can wait until HLS, as being an RFC now, makes the decisions and then we go back. So I think the innovations needs to continue. And Dash AF and Dash itself is doing the innovation around Dash, but we are very conscious about CMAF. And I think there's a great step forward with CMAF to basically harmonize the ecosystems. I just very cautious to say there is anything that impacts Dash because the work has been done in Dash, and we will continuously make sure that this alignment happens, but that also requires support by the industry in making sure that we can move forward in a common direction. So you can contribute to this. MPEG, I think, is still the core with the CMAF specification, but with all the aspects towards industry relation, Dash Industry Forum and CTA Wave seem to doing a good job here. So but it requires obviously that people speak out. And I think you made it all the way to lunch.